Welcome everyone. So in this session we'll be seeing on smart industry, digital twins, robot and augmented reality. So we will see how the digital and physical worlds are actually coming together to actually form this smart industry. And also this is a transformational industry or segment where it's no longer a normal conventional industry, but it is a smart industry. So we will cover 4 major building blocks of Industry 4.0, which is touching on digital twins. So in short, digital twins are the virtual models of the physical system. So you're creating a twin, but this twin is a digital twin. The next one is on the autonomous robots, whereby these are machines that operate with minimal human input. So they work on their own. That's why it's known as autonomous. Then we will also look into augmented reality, AR, which overlays digital information onto the real world. So if you remember many years ago, Pokemon Go, so it actually uses augmented reality. And finally, we will look into system integration, which actually puts together all this technology and make it work together as one intelligent ecosystem. Each one of these segment or pillars plays a distinct role, but the real power is seen when they are all interconnected. So let's move on to the first pillar, which is on digital twin. So what is a digital twin? It is actually what we call as a virtual copy of the physical system or process, which means it's like a living digital replica of the real world. Whether you can have machines, buildings, or even a human organ, but you can create a digital twin, which is, it's like a simulation. And this twin, it's not just like image. It is actually a real-time virtual digitalization, whereby it gets updated with data in real time from sensors, IoT device, and machine logs. So it is constantly being updated with real time. And it is actually built using all these various sensors and simulation models. So it is an exact replica of the physical system or a particular process. But when why we actually use them, why we actually want to actually apply digital twin, because they allow us to simulate, what if scenarios. What if certain things can go wrong? What ifs? Monitor the system remotely. We can actually try to predict. Monitor the system is supports monitoring. We can also see how we can actually optimize the processes without even touching the real physical system, because we have the digital twin. So we can see what could go wrong. If this thing goes wrong, what will happen? So instead of us doing or creating the various simulations or scenarios on the real system, we can create all those scenarios in the digital twin. This is something like in many years ago when I was doing certification for ethical hacker. So we actually use what we call as the virtual machine. So in this virtual machine, we can actually send the viruses to actually see how it destroys the hard disk rotation and how it burns out the PC. But we are just simulating that scenario on the virtual machine. It's not on the real machine. So of course we can see how the virtual machine get damaged when it actually got attacked by the virus, but nothing happens to the real PC. So we can actually simulate it. Similarly, like we have the digital twin. So this is like a virtual computer as well. So we can also optimize the process just by tweaking certain parameters and see how would it actually affect the outcome. So without even touching the actual physical system. Then if it works, then we can actually apply on the physical system. And of course you can actually predict for any analytics for in the future case scenarios. So we can actually experiment various kinds of scenarios safely and also smartly. So that's why we actually have this digital twin. So some of the manufacturings these are just not a theoretical thing or something that you see in movie, even though it may look like that, but this is something already in practice. They are actually used in various applications. So you can see in manufacturing, they are actually used to optimize the machine performance and also try to reduce downtime. And in energy utilities, we actually use them to see how to model grid behavior and also fault prediction. So instead of, we try to preempt certain faults to see how it would affect the grid, but we are not doing it on the real grid. So we are doing it on the digital twin. And of course, not limited to, there are various applications. We are just seeing just a little few applications in healthcare, patient treatment and simulations, where patient specific digital twins are being developed for personalized treatments. So of course, what are the benefits across all these examples is that they can actually reduce the risk, reduces downtime, improve efficiency, provide actionable insights based on real-time data. So in other words, they actually make the system smarter and more responsive. So that is actually the role of digital twin. So let's see, there is a video on digital twin. Let's actually look at this.
Digital twins, the innovation backbone of the future, delivering virtual representations of real-world products, systems, and cities. For example, the digital twin of an electric motor not only showcases form, but also analyzes functions, from the rotation of the shaft to thermal conductivity to data from sensors and beyond. What's more, the digital twin continuously evolves, thanks to the flow of data, user experience feedback, and new input, and it's greatly impacting development, production, and operation. In development, a product's behavior can be simulated and tested long before a physical prototype has been built. Siemens utilized the digital twin to develop a world record-setting electric aircraft motor that not only weighs 50 kilograms, but is also 5 times more powerful than comparable electric motors. But it doesn't stop there. Digital twins also unleash the power of 3D printing. In a recent Siemens study for gas mixing systems, insights from the simulation of form and flow behavior were combined with generative algorithms. The result? A truly unique channel shape and configuration, one significantly more efficient than anything previously designed. Even entire factories down to individual machines can be simulated and tested. For instance, robots. It's difficult for them to perform milling tasks because large forces in the manufacturing process lead to inaccurate movements. But with the digital twin, the forces that push the robot away from the milling path can be calculated and compensated in real time, keeping the robot in its path. When it comes to operations, digital twins can compare the sensor data of a real point in real time with the simulation of its point. The availability of the point parallel to operations can be reliably predicted, and sudden disruptions become a thing of the past. But this is just the beginning, and Siemens is already driving the future. Merging digital twins with artificial intelligence allows computers to independently design advanced products. Siemens is realizing this potential right now with Californian startup Hackrod, which aims to build customized sports cars. For development, production, and operation, the digital twin breaks with traditional paradigms and opens up extraordinary possibilities. That's why digital twins are the innovation backbone of the future.
Siemens, ingenuity for life.
Okay, so we saw in this video, of course, we're not promoting Siemens. Just that this is one use case that we actually have seen. How we can see in various applications that how they actually use a digital twin to try to see in automotive how the car would be assembled. In the fast moving train, we can see how the track changes all are actually done on the digital twin, and in the aircraft is actually the motor. The blade's motor is actually has been they developed the virtual twin first before they even come up with the real system. So these are some of the various aspects of a digital twin. So next we are going to look at the next pillar, which is on the autonomous robots in the industry. So now we are actually, earlier what we actually looked at is the digital twin, which is a digital representation of the physical system. Now we are actually looking at the physical automation, which are autonomous robots. So these robots of course comes in various forms. We have the AMR, which actually stands for autonomous mobile robots. They are able to move freely around environments, for example like logistics in warehouse, so they are able to move freely. And then we have these AGVs, which are automated guided vehicle. So they follow predefined routes using tracks, or they use certain markers. This is what we call as the guided path. And then you have cobots. Cobot stands for collaborative robots. They are actually designed to work safely side by side with humans. And of course we have drones and humanoids. They are used in specialized tasks like inspections or customer interaction. And these robots are able to handle repetitive, hazardous or precise tasks, helping industry boost productivity and also maintain the safety. So there are a lot of applications, but we can see that in most of the time in assembly line, car manufacturing, we are able to see a lot of robots are being utilized here. Packaging and warehouse automation, this is quite the in thing, where a lot of robots, AMR and also AGVs are being used in the warehouse automation. So we also seen one of the robots, which is humans and robots working side by side. So these are, unlike traditional robots that actually operate behind cages, like if you go in the manufacturing site, the traditional robots, they are actually confined within an area whereby to ensure the safety of humans. These collaborative robots or cobots are actually designed to work with people, not actually replace them. So they actually come with some safety features like force sensors and motion detection to ensure that they are able to interact safely with humans. They are actually very useful for tasks that are too delicate for full automation, or when a quick reprogramming is actually required. They actually help to reduce the physical strain. So they actually always share the workplaces with human, and also they help to reduce the physical strain for human workers and allow factories to adapt quickly to changing the production needs. So they are assisting humans, not to replace them. So this is actually the essence of a human robot collaboration. So actually trying to combine the human intelligence and also adaptability with the robotic precision. Let's go to the next one. So the next pillar that we are going to look is known as the augmented reality overview. So what is actually AR? So earlier we actually going through the flow, we have seen the digital twin, then we looked at the robot part, which is actually the physical aspect. Now we are seeing on how to actually enhance the human side of operations by using augmented reality. So augmented reality, it actually overlays digital element, like for example certain instructions. I think if any one of you have used Google Maps, and while you are actually using the Google Maps direction, have you experienced that you're pointing your camera to a particular place, building, then you'll see that on the screen you'll show that arrow. That's like instruction. Okay, go this side, go move this side, and things like that. So if any one of you have used Google Map with an augmented reality assistance, you can actually see that. And this is real time. Sometimes I tried to use it before, so it's quite useful, but you have to make sure that you position your camera correctly. So that's the challenge. So it uses devices like smartphone, tablets, or specialized headsets and things like that. Sometimes I think in the earlier video, I'm not so sure how many of you noticed in the train simulation, there's one person wearing something like a headset. The AR kit by Apple, or AR Core by Google, or Microsoft HoloLens. So all those are augmented reality kit, and they can actually help the developers to build this immersive kind of experience. So through AR, it actually enhances the perception and decision. Later I'll show you one video where how you can actually use the AR to see if you make a certain placement of the switch gears, how would it look like in that particular place, which is quite interesting. And I think they have also implemented a lot of things in, for example, like house renovation. When you want to renovate your house, you want to know how your house space will look like when you actually put a sofa here or sofa there, without even putting the physical thing. So using augmented reality to see how it actually look like. So there are a lot of applications of augmented reality in industry. It is actually increasing especially in factory floors and also in field operations. For example, if a technician can actually wear an AR glasses and see live instruction overlaid directly onto the machine that they're fixing, so you can actually get an assistance. They can wear these goggles, and the local technician can receive instruction on which screw to tight and things like that. So this is actually eliminates the need to go through the manuals or things like that. So directly, this is a very, very interesting way of utilizing AR in the industry. So augmented reality is also used. So that's the first one, remote support. So a person can actually wear the AR and receive instruction. The person from the real expert could be another different country, but he's able to see what you're seeing, and he's able to actually point to you which part of the machine that you need to repair, and you can see it from your goggles, AR goggles or glasses. You can also use it for training, to train workers, to give an immersive step-by-step simulation. Especially useful for complex or high risk tasks. So this we can actually also see in TNB switch gears training. So they actually use this augmented reality, or in some cases they use completely virtual reality, so that they can actually try to perform this session or whatever step that they're actually doing step by step. And if we actually explode, explode means in the sense that it's virtually explode, so you'll know that there's no harm is actually being done on the physical self or the humans. So but it gives you an idea what happens if you wrongly do and things like that virtually. So it is very, very good for training purposes, and also for assembly and inspection. So you can actually get remote support to do inspection of a particular machine step by step, overlay. First you remove this, then second you remove that. So you can do it all through augmented reality. So with all this, what are the outcomes? It actually helps to reduce the training time. You can actually avoid errors. You can save lives actually, especially when dealing with high voltages and things like that. Or you can use augmented reality or virtual reality. And also enable remote support where expert, as I mentioned earlier, in another location, but it can able to guide that on-site worker in real time. So here's one video which I just mentioned, how you can actually try to do some visualization of switch gears in augmented reality. So here in the video you have watched how the lady was actually using a tablet, of course, in this case, and uses augmented reality to see if we place a switch gear at that particular place, how it actually look like, and they can actually man or tilt the tablet in different angles to view the different angle of the switch gear. So it's quite interesting how all this augmented reality plays an important thing. And of course now we are actually looking at the integration of all these various pillars. So we have actually discussed on the digital models, we have seen smart machines and augmented guidance, but how do the system talk to each other? So that's where we actually see the system integration comes in. How they actually connect the sensors, machines, the software and people, so that they worked in harmony. So it enables the real-time data sharing and allows decision making across different layers, from top to bottom hierarchy. So without integration, of course, these technologies will become isolated. They can't really, of course, they can be used separately, but let's say if you are looking at augmented reality and you want to see the real incoming data, how it actually looks like, so you need to integrate it in all these various other pillars as well. So with the integration, then what you get a seamless physical digital collaboration. So you get a synchronized data driven enterprise, which is agile and also very, very intelligent. So all these various things that we have actually seen is can be leveraged, and the through integration we can actually get a seamless physical digital collaboration. So there are two types of integration. One is actually known as the horizontal integration. So the horizontal integration means it actually connects a particular company across the value chain, like for example linking the suppliers, manufacturers, distributors and customers. So this allows better coordination, reduce inventory and also faster response to particular demand. So remember that this horizontal means across the company and also the value chain, suppliers and things like that. Whereas when we look at vertical integration, this is a connection inside the company. This is outside the company. This is inside the company. So from sensors on machines to manufacturing. So MES actually stands for Manufacturing Execution Systems, and ERP is Enterprise Resource Planning Platforms. So MES is like you can see that how it acts like a floor supervisor. It actually monitors all the real-time operation, production schedules and equipment health, whereas ERP is more like something like a CEO dashboard kind of thing. So it handles all the finance aspects, inventory, HR, procurement, strategic planning, etc. So together, of course, with the horizontal integration, which means outside of the company, and also vertical integration, the company can actually function as one unified system. So in both horizontal integration and vertical integration, we are able to see how the digital twin and augmented reality and all these autonomous robots can actually come in hand in terms of the horizontal integration and also vertical integration. So what we have actually seen so far is we have seen on the digital twin. So digital twin gives us insight into our systems. It's a digital twin. And we have also seen robots, which is actually provide some physical automation and precision. So this one we can see this can actually fall also both under horizontal integration and also vertical integration. And we have seen AR, how it actually augmented reality helps to enhance human capability and also learning. And of course we have seen on integration, so to ensure that all these technologies they work together. So the smart industry, the 4.0 of tomorrow is actually not built just by using one single tool. It is by connecting all these various tools, people and also data into an integrated ecosystem. So all these pillars interconnected together and working synchronously, that forms the smart industry. So this is a short presentation on the smart industry. So I hope that this has given you some insight on some of the pillars of smart industry. Thank you.